Hello all, this screencast is going to be on different types of roofs. This is a great time to introduce roofs because we've been going through the properties of material and the structural aspects of material. And when we speak about structural aspects, roofs are probably one of the most important pieces of our structure that we do a strong structure on and select materials appropriately. So it's going to be an introduction to roofs and a moderately in-depth talk about it. Now, I know a lot of you know a lot about roofs already. You've come through 101. For you, this could just be a quick review. Feel free to breeze on through it, but you're going to pick up a lot of little details that I don't go over in 101 now. So, let's get started. So, roof styles. Wow, these are some cool pictures, but realistic also. Look at this. What are we? 7 feet of snow on that roof and it hasn't collapsed. Also, you look at this little structure down here too. Well, just a great example of structurally sound roofs and also the type of loads that can be carried by a roof and what a roof has to withstand as far as the elements go. So when we start looking at different styles of roofs, we're talking about the actual shape of the roof itself. So just take a quick look through here. What I've done is the most common style roofs, starting with a shed roof. Very simple, basic roof, sheds the elements pretty well. Gable roof, again, moderately simple roof, sheds the elements well. However, it is a bit of a wind catch here. And speaking of wind, a shed can also do the same. A hip is a great roof. It actually holds up very well in storms. It has 4 different slopes typically on a hip, but a little bit more complex. Then you get into the combination of roofs, dormer, which I'll talk about a little bit later, but typical gable with a dormer. Flat roof, not really flat. There has to be a slight slope, like a 1/4 inch over a foot, which we'll get into shortly, which is a very slight slope. Gambrel, gambrels and valleys, and hips with valleys. There's valleys. So this is a wide variety of roofs. Now, when you select your roof, you're also going to have to talk about the slope of the roof. In other words, the pitch or the angle of the roof. I'm going to talk a little bit about building materials right now that go on the roof because the slope right down here in red, look at this, dictates the material. Okay? In other words, depending upon the material you select, be it metal roof, be it a tile roof, or a typical asphalt roof, you have to have a specific slope for that. Asphalt shingles, for instance, cannot go on a roof any lower slope than 212 because what it does, it sheds the water. Okay, the slope of the roof sheds the water. Asphalt shingles need a steeper sloped roof to shed the water. So that is one of the features of asphalt shingles. Bottom line is you are going to have to look at specifications. A lot of metal roofs, you can get down to a 1/4 inch, 1/4 inch slope for every 12 inches it runs, and you can use a metal roof. Wood shakes and cedar shake shingles, again, you got to be careful because of the fire element with these. These tend to be restricted in most areas here in Fort Collins anyway, in a lot of areas, especially up in the mountains. I mean, what's going on right now with the wildfires is a great indication. And slate. The reason I put slate in there is the weight of slate. That's a big dead load on a roof. So I talked a little bit earlier about pitch. What is it? Well, it is referred to as the rise and run. When I look at a slope of a roof, I'll call it a 712, pronounced just like that, a 712. What that refers to, it rises 7 inches or 7 increments and runs horizontally 12. It can be 12 feet, 12 yards, 12 meters, whatever. And the run and the rise just have to be on the same incremental scale. In other words, in inches, feet, whatever. So if it rises 7 inches, runs 12, it's called a 712. Just happens to be a 30-degree slope. I don't ever want you guys, sorry about that. I don't want you guys ever to start worrying about slopes, okay, as far as memorizing the angles of slope. What I want you to realize, though, is, when we start down here into the 312s, we'll consider these low-sloping roofs. 412s are going to be into medium all the way up to 712s. Above 712 becomes a steeper slope roof. This is important because when we select a roof in particular areas, high snow, high wind, high rain, things like that, the slope really, really is a factor in it. Okay, so we now know the pitch of roofs, also known as the slope, the angle of roofs, is very critical to our selection. Now let's take a look at 2 different types of roofs that we have when we start building them up. One kind is a roof truss, and the other is a rafter. What is a truss? Here's the technical definition of a truss, okay? My definition for you guys is it is an engineered roof component. 99.9% of the time, these trusses are made off-site. The great news about those, or about that aspect of it, is you can order your trusses right after you have your drawings put together. So, in other words, if you have your walls laid out and designed, I see your floor plan, we can start ordering your trusses directly off of that. Good news about that is I can start framing the house, putting up the walls before the trusses even show up on site. Time saver. Downside, trusses do cost a little bit more than typical rafters. Upside is they're really fast, they're very accurate, and incredibly strong. So, trusses, oh gosh, most of the roofs we do now are trusses. Every now and then what we'll do is rafters. Rafters are considered hand-built roof components. If you look at this, this is a great picture of a rafter. This is called a collar tie up here. It actually holds the rafters from splaying out. If you go back and you take a look at a truss, it is a triangular configuration. Down here especially is a good example. And this triangular configuration helps it, or prevents it, from totally splaying out. As you guys know, through trigonometry, this also creates an incredibly strong component. So, off to rafters once again. Rafters, again, if you're doing maybe a small house, a tiny home, shed, things like that, you're going to hand cut your rafters. They'll be built on that site. So rafters are good for that component. So we now know the slope of our roof. We know what we're going to order. Are we going to have rafters or are we going to have trusses? Once again, trusses are definitely the preferred means over rafters. So back to a little bit more in-depth view of what kind of roofs we have and the pros and cons of these types of roofs. Gable, super simple, quick, easy to do, okay? Some of you, when you start getting into Habitat for Humanity, I'm going to have you all design with gable roofs because they are inexpensive and very simplistic. Hip roofs, like I talked about a little bit earlier, they shed the wind really well, okay? Because any kind of wind that comes against the hip roof or elements tends to be parted by the lines of the hip. Gambrel, don't do too many, nor do you see many gambrels, also known as a barn roof, but it affords you livable space directly under a roof. It also gives you a lot of headroom in there. You can imagine if you did a 7-12 slope, 30-degree angle gable on here, you would hit your head on the corners every time. So gambrel has its place. Also, aesthetics play a big role in it. What type of house, what design. Another piece that you might want to think about is a pyramid roof. This really isn't true pyramid, and I'm going to yank that photo out of there. True pyramid does come to a point. It really does. It comes to an absolute point. And again, this is a great roof, simple roof, moderately simple for shedding the elements. And then you have a combination of gables, two gables coming together, cross gable. This is really classic in the Tudors and Cape Cods. And another design feature that we can put on roofs is going to be dormers. Dormers add several components. Aside from aesthetics, they're actually really functional. Two different functions when I start thinking about dormers. This is actually a livable space on a shed dormer up here. This is a combination shed gable dormer. Livable space. Down here, these are less livable spaces, but what they are is ventilation pieces. Okay, you guys are going to find out when we get into thermodynamics, and you most likely know already, heat rises. So what this allows you to do is set up a little bit of a convection current in the house. When you open the windows up above, it draws the cooler air in. Heat obviously rises, leaves through the gables. So gables not only are aesthetically pleasing and functional, but they serve a pretty substantial purpose when we start designing our building. So that's it then on the types of roofs that we're looking at. We covered the fact that you're going to have either trusses or you're going to have rafters, and it's going to be a specific slope that's going to be dictated by the rise and the run, the horizontal run and the vertical rise. The example I gave you guys was 7 rise, 12 run, 7, 12. Now, onto the actual water shedding components of a roof, and this is pretty intuitive, but it's really important because we're working on our foundations and talking about foundations. This is critical to preserving, how about that? Yeah, retaining your foundation. We're going to collect the water. Obviously, water is going to run downhill, and it's going to hit valleys and get into your gutters. The whole idea behind a gutter is you get the water away from your foundation system, okay? This is your grade, your slope of your land. You guys now know that foundations are always going to be above the ground by 6 inches minimally by code. Therefore, what you do is you grade or, create a contour of the land such that it moves the water away from your house. So catch all the water on your roof, direct it to a specific area, and get it away from your foundation. That is the key thing. The other part of roofs, functionality-wise, is they vent the entire structure itself. How does that work? It's kind of a goofy piece, and we're going to talk about this a little bit more in class. But believe it or not, this is your attic up here, okay? Your attic has to be, or should be, ambient temperature of what's going on outside. Down here is your soffit. Here is your fascia. Look at this. This is a vented soffit, and I've got a huge vented soffit sitting back in the lab that I will show you guys. We do a lot of called continuous vent soffit. In my little mock-up, what I have is just small vents, puck vents, and you can see those in my mock-up that's in the classroom. But here's what happens again. Heat rises. So picture this. Hot, sunny day. You have black asphalt shingles on your roof. Your attic is heating up. Well, you have insulation in here to prevent that heat from penetrating your house. But your attic gets really hot. You have to vent your attic. Hugely important. Gigantic important, okay? You're going to find out that we vent attics up top at the peak, and then we vent them down at the bottom also to set up, once again, that convection current. Heat rises. It goes through the top of your roof. It draws in the cool air down here, sets up a airflow, convection current, actually gets rid of the heat and the moisture in your attic. Because you guys, you come home from school, you turn on the shower, you get in the bathtub, and then, I don't know, you're cooking something on the stove, buckets of water, and you're just throwing a ton of humidity into your house. That can penetrate up through your attic. If you don't vent this properly, you get mold. So not only are roofs critical for keeping out the elements and keeping the snow off of our head, they're also critical in ventilating the entire structure and the entire system, the built environment that we're living in our houses. So that is a pretty comprehensive run through on roofs. I'm going to follow this screencast up with, we're going to get back into the properties and material with wood, and we'll keep moving on through, and in the next few days in the next week we will start thinking about working on your projects. Okay, see you guys soon. Bye.